This video corresponds with a double displacement reactions experiment in College Chemistry 1. In general, there's three types of double displacement reactions that you will be observing in this lab. The first type is what we call a precipitation reaction, in which case you mix two aqueous solutions together and a solid product forms. The thing that you'll be looking for when you do a precipitation reaction is the solution starts to get cloudy. Those aqueous solutions are usually transparent or clear and you can see through them. When a precipitate forms, the solution starts to get opaque or cloudy and you can't see through it as well. In the case of this reaction here, the solid precipitate is barium sulfate, which is a white solid, and you can see the white solid that forms in that test tube. Another type of double displacement reaction is what we call gas evolution reaction, and here a gas product forms as a result of your double displacement reaction. What you'll notice when you have a reaction that forms a gas is that your solution will fizz or it will form bubbles, and that happens as the gaseous product is released. In the case of our double displacement reactions, that gas is carbon dioxide gas that's being released from the reaction. The last type of double displacement reaction that you'll see in this experiment is a neutralization reaction between acid and base. Now, the thing about neutralization reactions is that oftentimes there isn't a visual result or a visual sign of chemical change. So one observation of neutralization reactions is that they're often exothermic and release heat. So you can see that a reaction occurred because your test tube would start to heat up. In this experiment, we aren't measuring temperature, so you won't have that data to observe. For this lab, you might observe your neutralization reactions as being no visible reaction, and that's okay. For this experiment, we're testing 6 different aqueous solutions, and I have a picture of those aqueous solutions here, along with the chemical formulas. Now, something to notice about this, and for double displacement reactions in general, is that we start with aqueous solutions. So in each case, we've got an ionic compound or an acid or a base dissolved in water. Most of the solutions are colorless with the exception of copper 2 sulfate, which has that characteristic blue color to it. The potassium iodide is stored in an amber bottle, but the solution itself is colorless. The way we're going to test these 6 solutions systematically is using these well plates, as you can see in the picture on the left. We have a template to label the 6 solutions at the top and to label the 6 solutions on the left-hand side. To react the solutions systematically with one another, we use this table here. First, we started with the columns and we added sulfuric acid in column A to each of the 6 wells going down column A, as you can see with the red X's here. We moved to the next columns here and followed along by adding each reagent that's listed on the top. For columns A through F, we added 4 drops of that reagent to all of the wells going down. At this point in time, our reaction plate has just one solution in it, just one reactant. To initiate our double displacement reactions and to add the second reagent, we looked at the rows on the left-hand side, numbered 1 through 6. So to add the second reagent, we started working across the rows, and for example in row 1 we added sulfuric acid to each of the 6 wells going across row 1. At that point in time we were adding the second reagent, and that's when we started looking for signs of chemical change. As part of the data for this experiment, you will look at a picture after the second reagent was added, and you'll record your observations of those results. Some of the reactions have no sign of chemical change, in which case you will record no visible reaction. You're going to use your observations for part A of this experiment for part B. And in part B of this lab, you are going to be looking at data of two unknown solutions. Just like before, we took the two unknowns and we added them all the way going down columns G and H, and we mixed them systematically with the 6 solutions that are labeled on the left-hand side. You're going to observe the reactions of unknown A and B with the 6 different solutions, and then identify the unknowns based on what you already know about the reactions from part A. Now, the thing you need to remember is that your unknowns A and B are 2 of those 6 solutions from part A. So really those columns G and H should match up with any of the 2 columns in your table from part A. You can compare the pictures in the data, and you can also compare your written observations of the results of this reaction. So I hope this video helps you visualize the reactions for a double displacement experiment in College Chemistry 1.